circular motion. Circular motion. Okay. What is meant by circular motion? In this chapter, we have already studied rectilinear motion. What is meant by rectilinear motion? A particle is moving in a straight line. Okay. That motion is known as rectilinear motion. Now, what is meant by circular motion? Okay. What is meant by circular motion? Okay. Now, a particle is moving along the circumference of circle. A particle is moving along the circumference of circle. That motion is known as circular motion. What is meant by circular motion? A particle is moving. Particle is moving along. Particle is moving along the circumference. Along the circumference of the circle. Circumference of circle. That motion is known as circular motion. Okay, that motion is known as circular motion. Okay, now for example, that motion of earth revolving around the sun. This is an example of circular motion. For another example, that planet, okay, planet revolves along the sun. That motion is also circular motion. Okay. Now we will discuss the new point, angular displacement. Okay. Now see here this diagram. A particle is revolving along the circumference of circle. That means that particle is in circular motion. Okay. This particle is moving in anti-clockwise direction. That particle is moving in anti-clockwise direction. Okay. Along the circumference of circle. Okay. Now see here, let A be the initial position. Okay, initial position of particle. Initial position of particle at time t is equal to 0. Okay, A is the initial position of particle at time t is equal to 0. Okay, now B is the final position of particle at time t. At time t. Okay. Now this angle theta. Now see here, a particle is at position A at time t is equal to 0. Okay. When this particle is moving in an anti-clockwise direction, it reaches at point B, that is the final position. So this makes an angle theta with the origin of the circle. That means theta is the angular displacement. Theta is the angular displacement. Theta is the angular displacement. Okay. R is the radius. R is the radius of the circle, and S be the arc length. Okay. Now see here, R be the radius of circle, and as angle described angle described by a radius vector, angle described by a radius vector in given time is known as angular displacement. Is known as angular displacement. Okay, so if that particle performs a circular motion, that means it starts from point A and returns to point A, that means it complete one revolution. That means the angle theta is equal to 360 degree, or angular displacement is 360 degree. Okay, if particle complete one revolution, if the particle complete one revolution means that particle starts from point A and returns to again point A, that means it complete one revolution, then angular displacement, which is denoted by theta, is equal to 360 degree. It also be written as 2 pi radian. Okay, angle also measured in radian. Okay, so now we want to find the formula for angular displacement. Okay, so the angular displacement is equal to arc length upon radius. So therefore we can write theta is equal to arc length s upon radius r. Okay, that means angular displacement is equal to arc length upon radius. Okay, therefore we can also write s is equal to r theta. R length is equal to r into theta. The unit of theta is radian. Okay, now next point, that is angular velocity. Okay, angular velocity. What is by angular velocity? The rate of change of angular displacement with respect to time. Okay, rate of change of angular displacement with respect to time. Okay, now see here, the angular velocity is denoted by omega, not w, omega. Okay, and the formula for angular velocity is angular displacement upon basic concept. Okay, these are some basic concept: angular displacement, angular velocity. Okay, now next concept, that is angular acceleration. Okay, angular acceleration. What is meant by angular acceleration? The rate of change of angular velocity, rate of change of angular velocity with respect to time is called as angular acceleration. Angular acceleration, angular acceleration is denoted by alpha. Okay, the formula for angular acceleration is change in angular velocity divided by time. Okay, so let omega 0 be the angular velocity at time t is equal to t0, and omega t be the angular velocity at time t is equal to t. Okay, so formula for angular acceleration is alpha is equal to rate of change of angular velocity, that means omega t minus omega 0 divided by t minus t0. T minus t0. This is the angular acceleration, or angular acceleration alpha is equal to d omega upon dt. The SI unit of angular acceleration is radian per second square. Okay, this is also vector quantity. Okay, now see here, what is meant by angular displacement? It is defined as angle described by radius vector in a given time is known as angular displacement. If that particle covers one complete revolution, or that particle complete one revolution, then the angular displacement theta is equal to 360 degree. So it can be converted into radian as 2 pi. Now the formula for angular acceleration is, angular displacement is arc length upon radius. So from that figure, theta is equal to s upon r, or s is equal to r theta. The unit of angular displacement is radian. Okay, now see here, angular velocity. What is by angular velocity? The rate of change of angular displacement with respect to time. So angular velocity is equal to angular displacement upon time, that is omega. It is denoted by omega. So omega bar is equal to d theta upon dt. Okay, so omega is equal to theta upon t. The unit of angular velocity is radian per second, or it can be written as rad per second. And angular velocity is a vector quantity, and the dimensions of angular velocity is L0 m0 t minus 1. Okay, now next basic concept, angular acceleration. The rate of change of angular velocity with respect to time is known as angular acceleration. Angular acceleration is denoted by alpha. So, angular acceleration is equal to change in angular velocity divided by time. Okay. Now we consider, let omega 0 be the angular velocity at time t is equal to t0 and omega t be the angular velocity at time t is equal to t. Okay. So, therefore, the angular acceleration alpha bar is equal to omega t minus omega 0 upon t minus t0, or alpha bar is equal to d omega bar upon dt. And the unit of angular acceleration is radian per second square. Okay. Now next point, relation between linear velocity and angular velocity. Now we want to find the relation between linear velocity and angular velocity. Now see, let us consider a particle, okay, which is revolving along the circumference of circle, okay, in an anti-clockwise direction. In an anti-clockwise direction. Okay. Let A be the initial position of particle. Let B be the final position of particle after time delta t. Okay. Delta theta be the angular displacement. Delta S be the arc length and R be the radius of the circle. Okay. So first of all we can write this. Let A be the initial position, okay. B be the final position, after time delta t. Okay. Let delta theta be the angular displacement. Okay. Delta S be the arc length, and R be the radius of circle. Okay. Now we know that the formula for linear velocity, okay, formula for instantaneous linear velocity, okay, we know that the formula for instantaneous linear velocity, that is v is equal to limit delta t tends to 0 delta s upon delta t, delta s upon delta t. This is the formula for instantaneous velocity. Okay. Now we know that the formula for angular displacement, delta theta is the angular displacement. So formula for angular displacement is arc length upon radius. So arc length is delta s upon radius r. Okay, that means therefore delta theta is equal to delta s upon r. So therefore delta s is equal to r delta theta. Okay. Now substituting this value in this equation. Okay, so we get v is equal to limit delta t tends to 0 r delta theta upon delta t, where r is the radius is constant at every delta theta upon delta t. Rate of change of angular displacement with respect to time, that means omega is equal to limit delta t tends to 0 delta theta upon delta t, that is angular velocity. So we can substitute here. So we get v is equal to omega. V is equal to r omega. This is the relation between linear velocity and angular velocity, or omega is equal to v upon r. This one also the relation between linear velocity and angular velocity. Okay. Now we will take this first relation, v is equal to r omega. Omega is equal to what? What is the angular velocity? Angular velocity means the rate of change of angular displacement with respect to time is theta upon t. If that particle covers one revolution, that means the angular displacement is 2 pi upon t. So we substitute this. So we get v is equal to 2 pi r upon t. Okay, 2 pi r upon t. So we know that the formula for frequency is equal to reciprocal of time period. So v is equal to 2 pi r n. This is the another formula for linear velocity. Okay, understood